Hey everyone, welcome back to the channel. In this last video, we explored some basic process management and CPU scheduling, how the OS is decided which program gets CPU time. So today we are going moving forward one step deeper to the another super important concept, memory management in operating systems. If the CPU is the brain of the computer, then the memory is a workspace where everything happens, and operating system is a manager that manages sure that this workspace is useful if it used efficiently. So left drive into it. So first question is why memory management? So why memory is required in OS? Imagine you are working on a desk. If your desk is too messy, you won't find anything quickly. So similar thing will happen in a computer also. So computers programs need the memory. RAM needs a RAM to run. RAM is also the RAM is limited for each one of the computer. The OS must allocate and some free memory smartly so that every process can run smoothly. That's what memory management is all about. It is allocating, tracking, optimizing the users of the memory. The main responses of the memory management is is allocation and deallocation, tracking, protection, and efficient uses. For the tracking, allocation and deallocation, it assigns a memory when the process starts and freeing it when it is ends. So for tracking, keeping all the records which are memory located are free or occupied. For the protection, making sure your one process doesn't override another memory. For the efficient use, maximize the performance and while avoiding the waste. For the memory allocation methods, there are two types of memory allocation, that is contiguous allocation and non-contiguous allocation. For contiguous allocation, each process gets one single block of memory. Simple but lead to the problem like fragmentation. The fragmentation, the external divided into two parts, that is external and internal fragmentation. For the external fragmentation, the free space exists but are the scattered, but it is not usable for the OS. Internal fragmentation have unused space inside the allocated blocks. For the second one is non-contiguous allocation. Process can be occupy memory at the different places. It is more flexible and efficient, achieved using a paging and segmentation, which can be discussed in the next later part of this video. For the packing and packing, what is packing? Paging. So breaking memory into the blocks. Paging solves the fragmentation problem. Memory is divided into a fixed size of block called frames. Processes are divided into same size of blocks. It is called pages. Pages are the map to the frames using the page table. For example, consider your processor needs a 12 kb and each frame is a 4 kb kilobytes. So and the OS is divided into the three page. And the process place stays where whenever the free frame exists in a RAM. So the advantages of these pages is the external fragmentation, uh, and it is easy to manage, but it comes with a disadvantages as it requires extra memory that needed for the page tables. It also causes the page table override. So the next topic is a segmentation. It is breaking by logic. The unlike the paging, the segmentation divided your memory based on the logical division of the program. The program have code, data, stack, heap. Each part is become a segment, and the OS uses the segment table to keep the track of it. Here, the some advantages of the segmentation. It is a more natural and maintains made machines how programs things. It also handles growing the data structure. The disadvantages are the external fragmentation. It may occur. The next part is the virtual memory, that is extended your RAM with a disk. Now, what happens if the RAM is full? That's where virtual memory comes into picture. Virtual memory uses the part of the hard disk as an external of the RAM. It actives the parts of the program to stay in a RAM. Inactive parts are temporarily moved to the disk. It is called swapping. When needed, they are brought back to the RAM. For example, whenever you notice your computer showing shutdown, showing down when too many apps are open, that's because of the virtual memory. The key techniques of the are the demand paging. A page is loading into a memory only when it is required. It produces unnecessary memory uses. Uh, the um, pros of this virtual memory is it allows running of a big program with a less RAM. It provides isolation and security. The cons are the slow. It is lowered in the real RAM. Uh, since the disk access is lower, it causes the thrashing if you too many tabs are open or saps is happening out. For this one, we use the swapping as a moving process in and out. The swapping is when your OS temporarily move the process out of the RAM to the disk and later it brings back. It useful for multitasking. It also helps to RAM helps you when the RAM size is limited. But too much swapping that is it will may create some system slowdowns drastically. So these are the from comparison of the paging and the segmentation. Here it is divided into the four features, that is division, purpose, fragmentation, and age of use. In the paging, it gives the fixed size of the blocks, and in segmentation it will give the variable size of the logical blocks. The purpose of this paging is to avoid the external fragmentation, and say for segmentation, it matches the logical program structure. Internal fragmentation is possible, and the external in segmentation, the external fragmentation is possible. uh, Paging is also easier for the OS, but not easier for the programmers. Segmentation is easier for the programmers. The next type is the real life example of memory management. Here, the Windows we use Windows, Android, iOS, and embedded system. Uh, for Windows and Linux, we use the paging plus segmentation together. They combine fixed pages with the logical segment for the best energy efficiency. For Android and iOS, we also uses virtual memory for multitasking, and in embedded system, it often skips the virtual memory due to limited hardware and limited value of RAM available. So why the memory management is matters here? It ensures that the efficient use of the limited size of the RAM. It allows you the multitasking without the program crashing. It provides you the security that prevent one app from the interfering with another app. It enables the bigger program to run on a smaller memory by using a virtual memory. So it also provides security that preventing one app from the inheriting from the another app. It also provides the multitasking, which your program stops crashing again and again. So even if you open the multiple tabs or multiple app in one single window or single system, it will stop crashing for that. It also enables the bigger program to run on a smaller memory as you have using the virtual memory. You remember what I told you about the virtual memory? Please comment down below if you remember anything about it. So let's move back to the conclusion of this video. Memory management is about allocating, tracking, and protecting your memory. Contiguous allocation is simple, but it suffers from fragmentation. The paging is divided into memory into fixed sizes and blocks. It also avoids the external fragmentation. Here in segmentation, it divided into the programs into logical parts. It is easier for the programmers. For the virtual memory, it extends the RAM using the hard disks that enables the large application to learn. So far, the so far so the for the next time when the PC feels slow, when too many apps are open, remember it's the OS managing your memory behind the scene. Judging between the RAM and a disk is to keep things running. If you enjoyed this video, don't forget to like, share, and subscribe this video more tech contents. In the next video, we will cover the fantastic topic like file systems in operating system, how your data is stored, organized, and accessed. Thanks for the watching and see you in the next one. Thank you. Bye.